In this video, we're going to take a look at the other common trig functions on the unit circle. So previously we said that if we're looking for cosine and sine defined on the unit circle, we can do so in the following manner. Take an angle and look at that angle's terminal ray. Where it crosses the unit circle gives us a point. That point has x value of cosine of theta and y value of sine of theta. Well, our other common trig functions that we use are tangent, cotangent, secant, and cosecant. We can take the ordered pair x comma y and defined tangent of theta, cotangent of theta, secant of theta, and cosecant of theta in the following ways. Tangent of theta is equal to the y value of that point divided by the x value of that point. Cotangent of theta is the x value of the point divided by the y value of the point. Secant of theta is 1 over the x value. Cosecant of theta is 1 over the y value. These four other trig functions exist so long as the denominators are not 0. So with tangent and secant, as long as x is not 0, then those exist. With cotangent and cosecant, as long as y is not 0, those exist. Now, instead of using x's and y's, since we've already established that x is the cosine of theta and y is the sine of theta, most times trig functions are written in terms of their relation to cosine and sine. Tangent of theta is usually written as sine of theta over cosine of theta. Cotangent is cosine over sine. Secant is 1 over cosine. And cosecant of theta is 1 over sine of theta. Once again, these exist so long as the denominators are not 0. Now, you can actually visualize what lengths these represent along the unit circle. There's a couple of good videos out there. I'll link that in the description of this video. But let's just talk through it. We know that the cosine of theta is the distance, the x distance to the point. You can either write it on the x-axis or you can write it up here. So that distance is cosine, that distance is sine. Sine is the y value. If you create a line perpendicular to the ray going from the origin out to the cosine theta sine theta point, if I create a line perpendicular to that and then stop it where it hits the x-axis and where it hits the y-axis, then it turns out that the tangent of theta is the distance from my point on the unit circle to the x-axis on that line. Again, that line has to be perpendicular to the ray coming in here. And cotangent of theta is the distance from the point up to the point where that line hits the y-axis. Secant of theta is the distance from the origin all the way out to where that line hits, that perpendicular line hits the x-axis. And cosecant of theta is from the origin, distance from the origin to where that line hits on the y-axis. Again, I'm not going to go through the details of why that's true. You can look at the details on one of those videos that's linked in the description of this one. Now, earlier in the previous video, we came up with the labels on the unit circle for various angle measurements. So anything that was pi over 6, pi over 4, pi over 3, which is 30 degrees, 45 degrees, and 60 degrees respectively, or those projected across the y-axis, or projected across the x-axis, or projected through the origin, we could find the cosine of theta and the sine of theta for any of these angles that are listed and any other angle that is coterminal with these ones. We can do the same thing using this diagram for the other trig functions. So let's take a look at example 1. We're going to ask for cosine of 2 pi over 3, and then sine of 2 pi over 3, and then secant of 2 pi over 3, and then cosecant of 2 pi over 3, tangent of 2 pi over 3, and cotangent of 2 pi over 3. So we're going to find the exact values of all 6 of these trig functions with argument 2 pi over 3. Again, we're using radians here. All right, so I take this picture and I search up the angle 2 pi over 3. It is right here. And so the x value of the point is -1/2. The y value is square root of 3 over 2. That gives me my cosine value. Cosine of 2 pi over 3 is equal to -1/2. And then sine of 2 pi over 3 would be the square root of 3 over 2. And that's it. That's the whole thing. Now, what we usually do when we try to find secant and cosecant and tangent and cotangent is we just use those values for cosine and sine along with the relations. Remember, secant is 1 over cosine of 2 pi over 3. Well, if cosine is -1/2, then we're taking 1 over -1/2, which is a -2. Similarly, cosecant is going to be 1 over the square root of 3 over 2. There we go. You can think of that as the reciprocal of square root of 3 over 2. So 2 divided by the square root of 3. Now, if you want to rationalize that denominator, it's going to be 2 times the square root of 3 divided by 3. Let's reposition that. There we go. Tangent of 2 pi over 3. Well, tangent is with the relation sine over cosine. So we're going to take square root of 3 over 2. I'll put that in parentheses. And divide that by a -1/2. When you divide, those denominators of 2 will cancel out and you'll get negative the square root of 3. So that's what tangent of 2 pi over 3 is. And then cotangent of 2 pi over 3 is also similar. On top, -1/2. That's cosine of 2 pi over 3. And on bottom, we take the square root of 3 over 2. Simplifying that gives you -1 divided by the square root of 3. Again, if you want to rationalize the denominator, that is going to be negative the square root of 3 divided by 3. So there we go. So that's how we can get our 6 trig functions with argument 2 pi over 3. We could do that same procedure for any angles on the diagram or any angles which are coterminal to the angles on the diagram. So why don't you try to push pause on this video and come up with the cosine and sine and secant and cosecant and tangent and cotangent of angle negative pi over 4. In a couple of seconds, I will show you how this is done. All right, so let's do those calculations based on this diagram. The first thing I want to state is that if we're talking about angle negative pi over 4, we're traveling in the clockwise direction, pi over 4 units. That's going to bring us to this spot. That's also the angle 7 pi over 4. So we end up with that ray, and that means we're at the point square root of 2 over 2, comma, negative square root of 2 over 2. So the x value of that point is the cosine, and that is the square root of 2 divided by 2. The sine of negative pi over 4, therefore, would be the negative square root of 2 over 2. The reciprocal of root 2 over 2 will be my secant, because secant is 1 over the cosine of negative pi over 4. So 1 over cosine. So we get the reciprocal of root 2 over 2. You can write that as 2 divided by the square root of 2. That's the reciprocal. Or if you multiply both top and bottom by square root of 2, turns out 2's will cancel out, and you'll just get a positive square root of 2 for your secant. Now, cosecant is related to sine in the same way that secant is related to cosine. So cosecant is 1 over the sine of negative pi over 4 in this case, which means that it is the reciprocal of negative root 2 over 2. So that's going to be negative 2 over the square root of 2, which, if you do some simplification, just gives you the negative of the square root of 2. Tangent is sine over cosine. You can think of this as sine of negative pi over 4 divided by the cosine of negative pi over 4. Now, if you think about what this is, sine divided by cosine in this case is going to be a negative square root of 2 over 2 divided by a positive square root of 2 over 2, which is simply negative 1. So tangent is negative 1. In a similar way, cotangent is cosine over sine. So cosine of negative pi over 4 divided by sine of negative pi over 4. It's pretty easy to see that that is also going to give me a negative 1. I'm going to get a positive root 2 over 2 divided by a negative root 2 over 2. I guess I can just copy and paste it from the above expression, but now changing the negative to be on the bottom and the positive one to be on the top. So I get negative 1 as the value of cotangent of negative pi over 4. So there you go. By the way, I haven't mentioned this earlier, but I do want to state that since cosine and sine are always x values and y values on the unit circle, and the unit circle only goes out to an x value of at most 1 and goes out to an x value of smallest negative 1, that means cosine is always going to be between negative 1 and 1. Moreover, sine is also going to always be between negative 1 and 1. If you think about what that means for secant and cosecant, it's always going to be 1 divided by some number between -1 and 1. So the smallest secant and cosecant can be an absolute value is 1. It gets 1 or higher in absolute value. Tangent is a ratio, so tangent can be anything. Here, tangent was -1, and so was cotangent, but you can get lots of different ratios. Like we saw in our previous example, we had a tangent which was above 1 in absolute value. Here, a cotangent is below 1 in absolute value. In any case, the unit circle does give us some restrictions on the values of cosine, sine, which translate over to restrictions on the values for secant, cosecant, tangent, and cotangent. Another angle on that diagram is pi over 2. I want you to push pause on this video and see what happens when we try to do cosine and sine of pi over 2, and then secant and cosecant and tangent and cotangent of pi over 2. I'll give you a couple of seconds so you can push pause on the video, and then I will show you how this is done. All right, hopefully you were able to do that. At angle pi over 2, we are at the point 0, 1. So that means cosine of pi over 2 is 0, and sine of pi over 2 is 1. Now here's where it gets a little bit tricky. Remember, secant is supposed to be 1 over cosine of whatever the angle is. So in this case, 1 over cosine of pi over 2. That would put us at 1 divided by 0. And that means secant of pi over 2 is undefined. Cosecant would be 1 over sine of pi over 2. And that's 1 over 1, which is defined. And obviously that's 1. So cosecant is defined here because we can divide by 1. Secant is not defined because we cannot divide by 0. Tangent is going to be sine over cosine. If you think about what that means for this particular case, when we have pi over 2 as our angle, tangent of pi over 2 is sine of pi over 2 divided by cosine of pi over 2. That would also be 1 over 0, which is undefined. Some people would write DNE for does not exist. That's fine as well. Undefined or does not exist. Either one is acceptable for me. Cotangent, on the other hand, is going to be cosine over sine. That's 0 over 1, which is 0. So notice that when our cosine was 0, secant and tangent were undefined, but cosecant and cotangent were defined. You can imagine what happens at pi or at 0 or any angle coterminal with those. Your sine would be 0, but your cosecant would be undefined and your cotangent would be undefined. So if we were at like pi or 2 pi or something coterminal with those. But there you go. With pi over 2, we get a couple of our trig functions to be undefined. That'll happen anytime you're on one of the axes. Anytime your terminal ray is along the x-axis, the y-axis. So that should be pretty nice. Anytime we can have an angle that we can reference in this diagram, either directly or being coterminal to one of the angles in the diagram, then we can define those 6 trig functions: cosine, sine, tangent, cotangent, secant, cosecant, of whatever angle. Now, the obvious question is, what if we have non-special angles? Specials that we cannot um, figure out from that diagram. Again, some special angles we can get exact values for using some tricks that we'll learn later. But most of the time, it's going to be more efficient just to turn to our calculator and use our calculator. So let's find approximate values for cosine, sine, secant, cosecant, tangent, and cotangent of the angle 8 pi over 5. All right, so let's go ahead and do this. Now, again, I'm just going to utilize my calculator. Since the angle is in radians, make sure your calculator is in radian mode. So cosine of 8 pi over 5 is about 0.3090 if I round to 4 decimal places. I think I'll round to 2 decimal places right now so that I am consistent. So sine of 8 pi over 5, I just typed that in. That's negative 0.95. Again, notice that cosine and sine are always going to be between -1 and 1. Secant is going to be 1 over cosine. So we can do 1 over cosine of 8 pi over 5. That's what I'll be typing into my calculator. And when I do that, I get about 3.24. In a similar way, cosecant is 1 over sine. That's what I'll be typing into my calculator. And that gives me a negative 1.05. I like to type this in directly. Don't use the rounded values. If you write 1 divided by 0.31, then you could really get thrown off. Use the exact values when you type them into the calculator. Now, tangent can be calculated by taking sine divided by cosine if you want. Or another way, most calculators have a tangent button. And if you just plug in tangent of 8 pi over 5, you end up with negative 3.08, rounding to 2 decimal places. Cotangent you can do in a couple of different ways. If you wanted to, you can write cosine of 8 pi over 5, or type that, divided by sine of 8 pi over 5, and type that into your calculator. Another way is, notice that cosine over sine is the reciprocal of sine over cosine. So cotangent is actually the reciprocal of tangent. So 1 over tangent of 8 pi over 5 is another way to type that into your calculator. That gives you about negative 0.32. Again, these answers, I've rounded all of them to 2 decimal places, but whatever we're approximating to, however many decimal places we're approximating to, would be what you would want to round those to. Go ahead and try example 5 on your own. We want to find all trig functions with angle 10 pi over 11. Push pause on the video. In a couple of seconds, I'll show you how they're all done. So here we go. Cosine of 10 pi over 11. That's something, again, I just type into my calculator, making sure that the mode of my calculator is in radian mode. When I do that, I get a negative 0.96 roughly. The sine of 10 pi over 11 gives me about 0.28, again, rounded to 2 decimals. To get secant of 10 pi over 11, it's 1 over cosine of 10 pi over 11. So that's what I type into my calculator. 1 over cosine of 10 pi over 11 is negative 1.04, roughly. Cosecant of 10 pi over 11 is 1 over sine of 10 pi over 11. That's what I'd type into my calculator, and I would get about 3.55. And then tangent of 10 pi over 11, I could type in sine over cosine, but it's easier just to use the tangent button on my calculator. When I use the tangent button, tangent of 10 pi over 11 is a negative 0.29. And then cotangent, I could type in cosine over sine of 10 pi over 11, obviously, or I can just do the reciprocal of tangent, and that's negative 3.41. That is rounded to 2 decimal places. So these are things we can just type into our calculator, or we can use what we know about the relationships between cosine and sine to these other functions and type the relationships into the calculator. Now, so far, we've looked at these trig function relations because we've been given the angles theta, and we've calculated cosine and sine using either our calculator or the diagram. And based on that, I calculated all these other 4 trig functions when the denominators, of course, are not 0. But another thing we can do is we can say, what if we have the cosine of theta? We know the output for that, and we know the output for sine. Can we find these other ones without knowing the actual values of theta? And the answer is, of course, if you know cosine and sine, then you can know the other 4 trig function values without even knowing what theta is. Also, you don't always have to have just cosine and sine. I could have cosine and tangent, and I could come up with the other trig functions based on my understanding of cosine and tangent. Let's do a couple of examples. First off, let's say I know that the cosine of theta is 0.86, and I know the sine of theta is negative 0.51. Can I find the other trig functions? And based on this, we're going to say what quadrant is that angle theta in. So what quadrant is the terminal side of the angle in? All right, so let's jump to it. Pretty straightforward if I'm given cosine and sine. If I want to find secant, it's 1 over cosine. So what that's going to be is 1 over 0.86 in this case. And if you calculate that, you get about 1.16. Cosecant is going to be 1 over negative 0.51. 1 over negative 0.51 is about 1.96. When I go to find tangent, tangent is sine over cosine. So sine is a negative 0.51 over a cosine of 0.86. That is about negative 0.59. And then cotangent is the reciprocal of that, 0.86 divided by a negative 0.51. And that is approximately negative 1.69. So there you go. That's how you can find the other 4 trig functions if I'm given cosine and sine of whatever angle theta is. Even though right now I might not know the exact value for theta. By the way, if we are asked what quadrant is theta in, since the cosine is positive and the sine is negative, well, what that's going to tell us, cosine positive means I'm moving to the right, sine negative means I'm moving down. So I should be in quadrant 4 there. So cosine is the x value, sine is the y value. Positive x, negative y, quadrant 4. Now we can do the same thing if I'm given two other trig functions, like cosine of theta is negative 0.31 and tangent of theta is a positive 3.06. You can actually use the relationships of the trig functions to find all four of the other trig functions. And then you can also decide what quadrant that angle theta is in, meaning what quadrant is the terminal ray of the angle in. Go ahead and push pause on this video and try this one on your own. And in a couple of seconds, I'll show you how it's done. All right, in this case, we were given the cosine of theta as negative 0.31 and the tangent of theta as 3.06. Now, in order to find the sine, what I would do is I would use this relationship of tangent. So tangent of theta is equal to sine of theta divided by cosine of theta. If I know tangent of theta is 3.06, and I know cosine of theta is negative 0.31, then I can multiply both sides by a negative 0.31 and come up with the value for sine of theta. So sine of theta, if I round it to 4 decimal places, I'd get an exact 0.9486. Rounded to 2 would be about negative 0.95. So I think I'll use the approximate value. These are most likely approximations anyways. So let's just use negative 0.95. And there we go. Now we're off to the races. I can say secant of theta is 1 over cosine. That is going to be 1 divided by the negative of 0.31. Typing that into my calculator gives me negative 3.23. Cosecant is 1 over sine. So we get the approximate value there of what we just found, 1 over negative 0.95. If I wanted to do the exact value, I could be a little bit more precise with that. 1 over negative 0.9486. But in either case, you might get a slightly different rounding version, but in either case, you get about negative 1.05. So whether you round your denominator to 0.95 or to 0.9486, you get the same thing. Cotangent is cosine over sine. That sine being a rounded number, I think what I would do is I would rewrite the cotangent as 1 over tangent of theta. Think of it that way. And now that I know the value it was given is 3.06, that's 1 over 3.06, which is about 0.33. So there you go. By the way, if we're trying to figure out what quadrant we're in, I usually use the cosine and the sine. Cosine of theta is negative, sine of theta is negative. So that means we're going left and down, which means we're in quadrant 3. So theta is in quadrant 3. And that's it. That's it. We found all 6 trig function values. We found what quadrant theta is in, and we got approximations of all those numbers. Now, in both of those cases, we use these trig function relations, and we were given two of the values. We were given cosine and sine once, and we were given cosine and tangent the other time. Obviously, if you're given cosine and secant, you're actually giving yourself the same two values. So you're not going to be able to, with these relations alone, generate out the others. Similarly, if you know tangent and cotangent, then you can't generate out all of the others from just these relations. Similarly, with sine and cosecant, you're given the same information. So if somebody gave us, for instance, one value for the trig function, let's say they gave us that cosine of theta is 0.58. I could clearly find secant of theta if I wanted to, but I wouldn't be able to find sine, cosecant, tangent, and cotangent of theta with those identities alone, the identities that we saw on the previous page. However, if you remember back to our last video when we defined cosine and sine on the unit circle, we also had a Pythagorean identity, which said cosine squared of theta plus sine squared of theta is equal to 1. Now, that Pythagorean identity is the most well known, but there are two other Pythagorean identities that relate secants and tangents and cotangents and cosecants. The way you get these other ones is you simply divide each term in our original Pythagorean identity by cosine squared of theta. Cosine squared of theta divided by cosine squared of theta is a 1. Sine squared of theta divided by cosine squared of theta is tangent squared of theta. Sine over cosine is tangent. And then 1 over cosine squared of theta is secant of theta. 1 over cosine is secant. In a similar way, if you divide all of these terms by sine squared, you get an identity involving cotangent and cosecant. These are also Pythagorean identities. They just deal with the other trig functions. So let's do that. Let's find the other trig functions using the Pythagorean identity and the relations. Now we also are going to have to know what quadrant the angle is in. So let's say we know that cosine theta is 0.58 and that our angle theta is in the fourth quadrant. Can we come up with the other trig identity or trig functions? We know that cosine of theta is 0.58, and we know that theta is in the fourth quadrant. Since I know cosine of theta, I'm going to use the Pythagorean identity involving cosine. That is cosine squared plus sine squared is equal to 1. If I plug in 0.58 for cosine, but I don't know what the value of sine is yet. So sine squared of theta, we'll keep that there. I can solve for sine squared. Now 0.58 squared is going to be 0.3364. If I subtract that from 1, I end up getting that my sine squared of theta is equal to 0.6636. Now I have to figure out how to solve this. Obviously, I take a square root, but is it the positive or the negative square root? Well, because we are in quadrant 4, and we know how quadrant 4 works. Quadrant 4 is here. That means I'm going to have a positive cosine and a negative sine. So when I take a square root, I want to take the negative of the square root. So I want to take the negative square root because we're in quadrant 4. And that means sine of theta is equal to the negative of the square root of 0.6636. I'm going to give an approximate value for that. That's about 0.8146. I misspoke. Sine is going to be the negative because we're in quadrant 4. I just went through that. And so sine of theta is negative 0.8146. Now I can do all of the things that I want to. Secant of theta is 1 over cosine, so 1 over 0.58 is about 1.72. Cosecant of theta is 1 over negative 0.8146. You could use the exact value if you'd like. That's about negative 1.23. Sine over cosine, we get negative 0.8146 divided by 0.58. That's about negative 1.40. And then cotangent is the reciprocal of that. So you can figure that out. You can also write cosine over sine as well. That's about negative 0.71, et cetera, et cetera. So using the Pythagorean identity, along with my relations that I know, can generate out all of these trig functions, as long as I know what quadrant we're in, because I needed to figure out that I needed to take this negative square root because we were in quadrant 4. Go ahead and try example 9 on your own. We know that the secant of theta is 3 and that theta is in the first quadrant. In a couple of seconds, I'll show you how it's done. Okay, so we know that secant is 3, and we know that we're in the first quadrant. That means both cosine and sine are going to be positive values. All right, so first quadrant moves right and up. So positive x value, positive y value. So cosine and sine are both positive. To get any other values, first off, let's just start with cosine. If 1 over cosine is 3, then cosine has to be the reciprocal of 3, so it is 1/3. Now you can do one of two things. If you want, you can use the Pythagorean identity with secant in order to find tangent, and then plug in the tangent and find sine, find cotangent. The other is, since secant and cosecant are so closely related, right now, if I wanted to, I could use the cosine Pythagorean identity, the one that involves cosine, I should say. So cosine squared plus sine squared of theta is equal to 1. So now that we have secant, we have cosine, it really doesn't matter which one we use. I think what I'll do, because it's easier for me to calculate with cosine and sine, is I'll use the fact that cosine is 1/3. So we have 1/3 squared plus sine squared of theta is equal to 1. 1/3 squared is 1/9. So we get that sine squared of theta is equal to, this would be 1 minus 1/9, which would be 8/9. And then since we're in the first quadrant, we would take the positive square root. Now that means that sine of theta is equal to the positive square root of 8 over 9. The square root of 8 is 2 root 2. The square root of 9 is 3. So that's 2 times root 2 over 3. That's what the sine value is. Now, this is the exact value for sine, so that's a nice thing. I don't have to use an approximate. I already was given secant, that was a 3, so cosine was 1/3. Cosecant is going to be the reciprocal of sine, so that's going to be 3 divided by 2 root 2. If you multiply top and bottom by the square root of 2, you end up getting an exact value of 3 times the square root of 2 over 4. Again, that's when I multiply top and bottom by the square root of 2. Sine over cosine, well, sine is this, cosine is this. The denominators of 3 are going to cancel each other out. And so what's going to happen is that sine over cosine is going to give you 2 root 2 divided by 1. I don't have to write the divided by 1 part. I just get 2 root 2. And then the cotangent is going to be the reciprocal of that, which, again, if we want an exact answer, 1 over 2 root 2. And then rationalize the denominator, you'd get square root of 2 divided by 4. So these are all exact values for cosine, sine, secant, cosecant, tangent, and cotangent of my angle theta. Okay. You could have also given the approximate values too by just plugging these into your calculator. In this example, we're given the tangent of theta is 2.1 and theta is in the third quadrant. Since theta is in the third quadrant, I know both my sine and cosine values will be negative. Go ahead and push pause on the video, see if you can do this one on your own. All right, so we're given that the tangent is 2.1 and that the angle is in the third quadrant. Since I'm given tangent, I'm going to turn, I could find cotangent. Cotangent obviously is 1 over 2.1, whatever that turns out to be. I'll type that into my calculator right now. That's about 0.48. Okay. But I can't get any other of these just based off of the standard relations. So what I do is I turn to the Pythagorean identity, and the Pythagorean identity that involves tangent says 1 plus tangent squared of theta is equal to secant squared of theta. So since tangent is 2.1, I know 1 plus 2.1 squared is going to be the secant squared of my angle theta. And 1 plus 2.1 squared is 5.41. So we get 5.41 is equal to the secant squared of theta. Now here's where the quadrant comes into play. Since theta is in the third quadrant, cosine is going to be negative, which means secant is going to be negative. So I'm going to take the negative square root. So secant of theta is going to be equal to the negative of the square root of 5.41, which is approximately negative 2.33, approximately. Now that's the secant. The reciprocal of that will be cosine. So if I take 1 over negative 2.33, I get about negative 0.43. You could do the exact value as well. Again, I'm just taking the reciprocal of secant to get that. Now that I know cosine and I know sine, I can use a lot of different tools if I want. I could use the Pythagorean identity to get sine, but it's probably easier just to utilize the fact of the tangent of theta is 2.1. So that means sine of theta over cosine of theta is 2.1. And now knowing that the cosine is about negative 0.43, I get about negative 0.90 as my sine value. Again, that's an approximation there. So sine of theta is about negative 0.90. And then cosecant, once again, we're going to give approximation, and we just do 1 over sine. So 1 over negative 0.90 is negative 1.11. Now, again, I've been using rounded versions here. If you use more exact versions, they might round to a slightly different value, might round to like negative 1.09 if you used exact values, or negative 1.12 or something like that. But it'll be very close to this one. So in this case, we had to use the Pythagorean identity involving tangent. Once we did that, we came up with our value for secant, which gave us our cosine, which just led to all of the trig function values. Again, using Pythagorean identity and the trig relations, we came up with all 6 trig function values. So these trig relations, as we can see, can be used in lots and lots of different ways. And that ends this video on the 6 trig functions on the unit circle.